Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything that was covered in week 9. So we're going to start off by looking at the equation of a tangent. We're going to calculate the equation of the tangent to this curve here at the point 1, 0. So we're calculating the equation of this line here. A tangent hits a curve just once. So because a tangent is a straight line, we can use the rule for calculating the equation of a straight line. Any straight line has the form y equals mx plus b, where m is the gradient and b is the y-intercept. So I know it's a bit confusing, but all of these words here, derivative, gradient of a tangent, slope at the point, instantaneous rate of change, they all mean the same thing. So to calculate the gradient or slope of a tangent, we just find the value of the derivative, y dash, at the point. After we've done that, we sub mx and y into this equation here and solve for b, and then we will have our equation. So if this is our equation here, the derivative, we just move the power to the front, decrease the power by 1, move the power to the front, decrease the power by 1. This is the gradient function of this curve here. So to find the derivative at this point, we just substitute in x equals 1. So the derivative there will just be 3 times 1 squared minus 2 times 1, and that equals 1. I have found the gradient of this tangent must be 1. So now I'm going to take my equation y equals mx plus b. I'm going to substitute m for 1, which I just calculated, and I'm going to substitute x and y from the point I'm given. So x becomes 1, y becomes 0. I now solve this equation for b, which is really easy. I subtract 1 from both sides to get b equals -1. So it turns out that this tangent, it has equation y equals 1x, or just x, minus 1. So it's actually this line here that is the tangent. All right, let's now have a look at stationary points. So sometimes the equation of the tangent will be something really simple like y equals 3 or y equals 4. The stationary points, also called turning points, occur when the gradient of the tangent equals 0. So they are places where the tangent is a flat, perfectly horizontal line. So this curve here has 2 stationary points, one here and one here. So if I want to calculate the stationary points, I just differentiate the function, which I did on the previous slide, and I find where the first derivative equals 0. So if 0 equals 3x squared minus 2x, I can just factorize by taking out the x, and I'm left with this. So using the null factor law, we have either x equals 0 or 3x minus 2 equals 0, which means x equals 2/3. So if x equals 0, substituting in, we get y equals 0. And if x equals 2/3, substituting in, we get y equals minus 4 over 27. So there are 2 stationary points, one at 0, 0, which we already knew, and this point here, which is at 2/3, -4 over 27. So you need to be able to not only find the stationary points, but classify them as a maximum or a minimum. So to do that, we're going to use the first derivative test and these facts here. So to use the first derivative test, set up a table like this with 3 rows. The x value, the value of the derivative at that point, and we'll also write here the direction in which the curve is going. So what we want to do is put our stationary points here, 0 and 2/3, and we need to pick a point on either side of the stationary point to see the direction the curve is going. So for this one, I could just pick x is -1 here. Now I want a value between 0 and 2/3, so I might just pick 0.5. And 1 over here. Okay, so this is the story. We know that when x equals 0, the first derivative equals 0 and the curve is flat. Similarly, when x is 2/3. But let's look at what happens on either side of it. So if I substitute x is -1 into this derivative here, I get 3 plus 2, which is 5. I get a positive number. Derivative is positive. Now, when the derivative is positive, it means the curve is leaning to the right. so it's leaning in that direction. It's increasing. On the other hand, if I were to substitute 0.5 into the first derivative, I would get a negative number. That means that the curve is leaning to the left. The curve is decreasing. As x goes up, y goes down. And if I substitute 1 into the first derivative, I get another positive number, meaning that the curve is leaning to the right. So this direction down here will help us determine whether the curve is a maximum or a minimum. So we can see here that 0 is a maximum. The curve is increasing, then it gets to 0 and stops, and then it goes down. So we know 0, 0 is a maximum. On the other hand, we found here that when x is going towards 2/3, it's decreasing, then it hits a minimum, turns around, and starts increasing again. We know here that this point, this stationary point, is a minimum. Now, we could tell that from the graph. I just wanted to show you how we could use the first derivative test if we don't have a graph. So, as an important point, we call these terms local max or a local minimum. So the reason is they're just the minimum or maximum value in a neighborhood. 0 is the maximum value of this blue function around this area of the curve. Similarly, minus 4 over 27, it's the minimum value of the curve just in this area. There are values of the curve that have a lower y value down here. So this isn't the lowest value that the function can ever take. It's just the lowest value in this neighborhood, hence why we call it a local minimum. All right, let's now look at sketching a derivative from a function. So here we have the curve from the previous slide. We're going to sketch its derivative function. So let's pretend we don't know the equation of this curve, because you need to be able to sketch the derivative when you're given a graph and you don't know it. All we really need to accomplish this task are these facts from the previous slide as well. They tell you the link between the value of the derivative and what the curve looks like. So let's sketch the derivative of this over here. Now, firstly note, we have two stationary points at x equals 0 and x equals 2/3. So that means the derivative will be 0 at these 2 points. So if this is the graph of the derivative, it will hit the x-axis at these 2 points, at 0 and again at 2/3. They will be the x-intercepts. So look at what this blue curve is doing. So for negative values, for values of x that are less than 0, note the curve is leaning to the right. That means its derivative is positive. So when we're graphing the derivative, when x is less than 0, when x is negative, this will have a positive derivative. So what will happen is its derivative will be above the x-axis. That's what it means to be positive. On the other hand, note that this blue curve has a negative derivative for x between 0 and 2/3 because it's leaning to the left. So that means when I graph the derivative of this function, it will be negative or below the x-axis when x is between 0 and 2/3. So if it goes below the x-axis and then somehow gets back up here, it must stop somewhere, turn around, and go up and hit 2/3 on the x-axis. Now, looking at this blue curve again, you can see after 2/3, for x values greater than 2/3, it starts leaning to the right again, and so its derivative is positive. So its derivative is just going to go up and keep increasing. And that sort of makes sense, right? Because we knew this was a cubic, and the derivative of a cubic is always a quadratic. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.